In this video, we're going to be adding the ability to add and remove blocks in our Voxel engine. And we will also be fixing our Voxel Automata rules to improve them and make it so the water can flow a lot better than it did in the previous videos. All right, first things first, we're going to need a camera to look around in our scene so that we can actually edit the voxels. So I'm going to create a empty game object and I'm going to call this player. And then we're going to put the camera underneath of it. I'm just going to rename that to camera. And I'm going to reset the position of both of these, as well as the player. And since we're going to be looking around in our scene, we're not going to want it to be orthographic anymore. So we're just going to reset that to just reset it to perspective. All right, now I'm just going to create a cube, really simple cube, just a cube. And that purely so that as the player in the world, we have something to tell whether we are actually moving around, and we'll delete it afterwards. All right, so now let's create a scripts folder outside of our voxels, because in this voxels folder is everything related to voxels. So now we're doing something slightly unrelated. So we're going to create a scripts folder, scripts. Rename that to scripts, and then we're going to create one more folder called player, and in there we're going to create a C# script, and I'm going to call it player controller. All right, let's open this up in Visual Studio. All right, so remove the default methods, and what we are going to do is let's get a, what do we want to do here? Let's get a we're gonna need private void update, and inside of update we're gonna do all our stuff. Okay, and then a serialized field reference to a private transform camera. And what I'm going to do for now is I'm going to use the simple input system instead of using the new input system, because that would take a long time to set up. I'm going to create a float. We're going to call this horizontal. It's going to equal to input.get axis and horizontal. Oh, that's not going to autocomplete. All right, and then vertical, and we're going to say vertical. So this is the Y, and or up, down, no, forward, back, and right, left. Okay. Now, when you go forward, we're going to say transform dot position is going to plus equal plus equal transform dot forward times vertical. Boom. And actually no, camera dot forward. So camera dot forward. So what we're going to do here is rotations can get pretty messed up if you don't know how to handle them. So in here, we're going to control the rotation of the player looking in the Y. So when we look left and right, we're going to rotate this one. And then when we look up and down, we're going to rotate the camera this way. That way, the rotations don't get messed up, and we can continue to look around the scene. Sorry, no, that one's going to control the, up and down. This one's going to control left and right. All right, let's reset the rotations on all these. And reset. All right. And then let's just move the player back again. There we go. All right. Now here we're saying is just move forward where the camera forward is. And now we're going to say move left, or move right and left, forward, back, where camera, or no, actually we can even use our where our, because we're going to rotate, right? So when we rotate this one, left and right is now, it's based on X. So when we rotate it, left and right changes. So we're just going to use the right direction, this arrow basically. And we're going to say transform.position. It's going to plus equal transform.x. We could say X, but it doesn't work. So it's just right. And that gives us a vector that points to in the x-axis. And then we're going to say times horizontal. All right, so we've got our movement. Let's go in here and add this to our player. And if we reset, well, actually, we don't need to reset it. Yeah, I don't like the fact that this is rotated, though. Okay. All right, now just pass in the camera. We're going to do the rotation in a second. Right now, we're just doing movement. So if I move forward and back, left and right, it's working. All right. And every time I click S and W, we're adding new sand and water blocks. So we'll fix that later as well, when we actually make it so we can add using the mouse just by clicking. And then select in different types using 1, 2, 3, 4, 5, and whatever. Something like that. All right, let's get the rotation. So for rotation, we're going to say float mouse X is going to equal input dot get axis, and it's going to be mouse X. And then float mouse Y is going to equal get axis mouse Y. And I believe that's correct, but just to check, you can go to Unity File, no, Edit, depending on if you're on Mac or Windows, but you just basically need to get to Project Settings. You can do this by going Build Settings, Player Settings. And actually, my bad, yeah, it's Player Settings, not Project Settings. Project Settings is something else, I think. Nope, it's the same thing. Okay. All right, so input should give us the input manager here. And if you look at the axis, you can see mouse X, and it is indeed called mouse X with a space, and mouse Y. This is the old input system, but we're just using it because it's easier. All right. Now for the rotations. So we're going to say transform dot rotate, and we're going to rotate ourself only in the Y. Rotate ourself only in the Y. So we're going to say new vector 3, and I'm going to say 0, 1, 0. And for that, I'm just going to say the mouse X, so moving left and right, is going to rotate us in the Y. So the Y points straight up from our head, and we're rotating in that axis. All right, we're going to need a speed variable, but just for now, this is going to work. And then rotate the child up and down, left, right, up, down. All right, so camera dot rotate. We're going to say new vector 3, and we're going to say in the X, so mouse Y up and down is going to rotate us in the X-axis, and 0 and 0. All right, with that, we should have full look functionality. If I click play, when I move my mouse around, I should be able to, and I can indeed, back up. And what I'm going to do is I'm going to look up and move forward, and then I'm going to look down. And so I can move forward in the direction that I'm looking. So if I go like that, I can go towards where I'm looking. If I look off to the right, oh my goodness. If I look off to the right, it's like this. So I'm having a lot of trouble looking because the mouse direction is incorrect. So left and right is correct, up and down is not. All right, let's change that. So up and down, I'm just going to invert it there. Let's click play again. Let's see if this is right now. So I want to look left, right, up, down. All right, cool. Now we just need to actually be able to move up and down using our keyboard. So E and Q are going to move us straight up and down without me having to like look up and then move forward and then look down, like super inconvenient. All right. For that, we're going to go to our project settings, input manager, axis, and horizontal and vertical. I'm going to copy vertical. So what I can do is duplicate, and underneath it, it'll just create another one. And I'm going to call this up and down for keyboard. And for this, it's going to be the positive button is going to be E, and Q is down. Q, E, I'm just visualizing how this feels. I think Q is actually down. Yeah, all right, whatever. In Unity, let me see. E is up, Q is down. Yeah, so, and then we can get rid of W and S because otherwise that'll cause problems. All right, let's do that. So, right under here, I'm going to say this is movement, and this is look. All right. Move up, down. All right, so transform dot position is going to plus equal our vector 3 dot up, or we can just say the camera dot up. I prefer just vector 3 dot up because it's global. And then we're going to also get our float up, down, and it's going to equal input dot get axis up, down. And that's an uppercase D. Let me just double check. Yeah, with a space. All right, so up, down, and boom. Now if I click play, back in Unity, I should be able to look up and move up and down with E. Oh, and it's inverted. So E is moving us down, Q is moving us up, and just add a negative right here. All right, so with that, should be able to look around in our scene. So E and Q, yeah. All right, so we've got the player moving around. Now we just need a way to add blocks. What I'm going to do is I'm going to add another serialized field reference private transform. And I'm going to call this the target. This is the place target. And you know what? I'm going to do this in a separate script. So let's go to the player, create another one, and I'm going to call this Voxel target. Yeah, we're just going to call it that. Add it to the player camera, not the player. Actually, no, just go ahead and add it to the player. Yeah. And we're going to take in two references. So a serialized field private transform. We're going to call this the forward direction. And actually, we're just going to call this the aim. Or no. Yeah, forward. And we're going to say serialized field private transform. Again, we're going to call this the target or the indicator. I wish I had a better name. Icon, I don't know. And then what we're going to do is in update, we're going to say, and we're going to say the indicator's position is going to equal the forward times 10, let's say, dot position, sorry. The indicator's position is going to equal the, let's just call this the camera's forward direction times 10 plus, no, actually, camera's, yeah, times 10 plus the camera dot position. So camera dot position plus the camera dot forward. And that should be our indicator's position. Yeah. All right, let's try that. So in the player, we have the voxel target. Let's drag in the camera. And the indicator, this cube we added, I said we were going to delete it, but let's actually use that. And go ahead and add that there. And now, if I start to look around, in my scene, you'll see that the cube is now directly in front of us, and that's what we're going to use to add it, to add voxels. Yeah. All right. Now, one other thing we're going to do is we're going to create a grid. So let's say we're going to snap that voxel to a grid. So, or not the voxels, the indicator. Snap it to a grid. So, and I'm just going to round the position. Let's see. New. Let's see. Rounded. Vector 3 grid position is going to equal a new vector 3, and we're just going to do all the math here that we did, except we're going to round it all. So let's see, vector 3.camera.position times 10. I don't know if you can do dot x on this. All right, looks like I can. Dot y and dot z. So what I did is, it looks weird, but this parentheses, the result of all this math is another vector 3, and then we're just saying dot x on the result of the vector 3 that we created from this math, which is pretty cool. All right, now we're going to do math f dot round, and I'm just going to do regular round. And that should work. Yep, mathf.round. Apply it to all of these. Because our voxels are a 1x1 size, the grid is just 1x1, so we don't have to do any weird math with round. We can just straight up use round. And now if I say grid position, and I click play again, I should be able to, let's just see. I should be able to, yeah, and it is indeed rounded. Now, one thing you might come across that might be annoying is doesn't look like it's actually working in the grid correctly. Oh, I know why. Okay, yeah, so create an empty game object, call this indicator, and the cube. Now our grid, let's reset this. Our grid works on our grid of voxels. The corner of every voxel is not at, because if you look at our voxel tables, let me just open this up. Voxel tables, scripts, voxel tables. If you look at this, these all start from 0, 0, 0. This is the corner of our voxel, and 1, 1, 1. So our cubes are offset. Like the back of the cube is not like this. It's more like this in the world, if that makes sense. And so what we just need to do is just 0 0.5, 0 0.5, and 0 0.5. Yeah, and the rounding is now working, but click out of there, and let's see, the indicator isn't at 0, 0, 0. The cube is also at 0, 0, 0. Oh, okay, I see what I did. In the player script, I never updated the indicator, so just drag that in instead of the cube. All right, now everything should work. Let's move. Let's look at this. Yep, everything is working. It's now inside, as you can see here on the scene. All right, cool. One thing I'm going to do is I'm going to change the cube to be slightly bigger, so 1.1. All right. So we've got our indicator position. Now, what we want to do is in our voxel store, we're going to need some sort of function called private void set voxel, right? Now in our automata rule, our voxel automata, we have this just only for a specific set of voxels locally. What we have to do is we have to convert a world position, so vector 3 world position, and we have to convert it to an index, a local index for a particular voxels, for our voxels. Now this is very easy. This would be very easy to do because our voxels are currently just centered in the world. But if our voxels were not centered in the world and we had lots of chunks, then that would not be the case. All right. Since I am planning on having more than just one chunk of voxels, one single, grid of voxels, we're going to want many grids of voxels. I'm no longer going to store the voxels in here like this. What I'm going to do is I'm going to create a private dictionary that's going to take an int3 for the key. And I'm going to need to be using unity.mathematics. And this is going to take an int3 and a voxel buffer. And actually, for now, we can just do it a byte array. Later, I'm going to be changing it to a voxel buffer so we can access neighbors. But for now, this is enough. All right. What we're going to do is call this our voxels. Yeah. And this is going to equal a new dictionary, and there you go. All right. So go ahead and delete that. Just delete voxels. All right. Now, what we're going to do is in update voxels, we're gonna go ahead and just start fixing all the code that we broke. But update voxels is going to take in an int3 key. Key for the voxels, and the callback is not going to need a key. Let me see. Render voxels, callback voxels, and what happened? Yeah. Okay. So now we got the key. What we can do is if voxels.try get value, pass in the key, and out byte array of voxel, and we're going to call this buffer from now on. So this is a buffer of bytes. So if we get access to that buffer of bytes, we will pass it in here. So otherwise, else we can debug.log warning, no voxel grid at plus our key. And there we go. We've got our warning. And now in start, we're going to create a grid by default, and we'll just use that one grid for everything. So voxels.add, and it's going to be a new int3. And actually, I think we can do int3.0. Yeah, int3.0, and a new byte array. And let's just do voxel constants dot resolution times voxel constants dot resolution, and we're also going to do voxel constants dot height and multiply that. So we created a new byte array that's the correct size, and because we don't want to do this right here a lot, we're going to create a function for that called private void load. And we're just going to call this load, and it's going to take an int3 key. And in here we can just do this, and instead of vector3.0, we're just going to do key. All right, and then here in start, I'm just going to load one chunk, and that's going to be a int3.0. All right. We're going to do update voxels. My bad. Update voxels is going to give us a voxels, and we're going to update that and then apply the changes. And I just wanted to pass this in right here. And then we can return voxels. There we go. All right, and this needs a key, so we're going to pass in a int3.0. All right, so using all of our own functions to update stuff. Cool. We don't need to get access to the voxels, because whenever we want to update them, we just do update voxels. All right, so we loaded, and now we need a set voxel. So our set voxel function, we can complete it with an int3 for the key. And actually, I take that back. We're not going to give the key. We're just going to give in the world position, and we'll figure out the key ourselves. So the key, the int3 key, is going to equal a new int3. And to calculate this, what we have to do is say, get the mathf.floor to int, and we will do that 3 times 1, 2, 3. And we can pass in the world position dot x, world position dot y, and world position dot z. All right, so because the world position, so the keys are every, like if the resolution is 16, the x and z, every 16 blocks, it's going to increase by 1. So what we need to do in the Voxel store is just say divided by voxel constants dot resolution. And let me think, is that it? Voxel constants dot resolution. Yeah, that is how we get the key. All right, so multiply this, multiply this, multiply this, and that's going to be height. All right, so get the key, and then we will say update voxels with the key that we created, and we're going to pass in this. And the other thing we need to calculate is now the index. So how are we going to get this XYZ index to actually edit the voxel? So let's see. For that, at the end we're going to return voxels. For that, we are going to have to do a lot more math. So this time it's going to be an int3, and this is going to be a index. And we're going to say a new int3, and let's just copy this since it's going to be pretty similar. So first, take the world position dot x, divide it by the resolution to create the 0.index. And I'm going to have to subtract it. So just give me a second here. I'm going to think about this and I'll get back to you guys. Figured it out. So we're going to have to convert this key from its local int3 ID to a key world position. And then all we have to do is just subtract the key world position dot x. And what this does is it creates a local index for the specific voxels in the grid. All right, so dot x and dot y and dot z. So y and z. All right, and then for the key world position, all we have to do is same thing here, and we can actually just reuse this. So key dot x times our voxel constants dot resolution, and height and resolution again. So height and y and z. All right, so with that we have our key world position, and this just, yeah, it just multiplies it to its world position again. And now with that we can say index, so we can say voxels at voxel utils dot get in, index, and index dot x, index dot z, and index dot z and index dot y. There we go. And that we're going to set it to the byte voxel. This is the voxel that we want to set it to. So voxel. All right. Now with this method, we're going to make it public, and we're going to move load below it, as well as start, since they are both private. And the public methods go up there, so we can easily see them. All right. And now in our voxel controller, or sorry, our player controller, we can say serialized field private voxel store, and in there we can say, oh my bad, not the voxel player, my bad, the voxel target. In the voxel target we will add a reference, close that, I don't know why that opened, and in here we can say if input dot get key, and let's just say key code dot spacebar this time, spacebar, and we're going to store dot set voxel, and our world position is just our indicator dot position, and the voxel we want to set is just sand for now. Yeah, this should work. So if we go back into Unity and got an error here. What is this? Update voxels. What is going on? Oh, that's right. So in the update for our voxel automata, we're going to have to take into account the fact that there's going to be many grids in our world. But for now, there's only one, and it's at int3.0. And we're just going to apply these rules every single time. All right. Hopefully there's no more errors. And I can clear it. Let's click play. Hopefully, if I... Oh, what's going on? What's going on here? All right. Now if I move up, and let's just hold space. And I'm not sure what's going on here. Oh, that's right. So in the inspector, I never set the voxel store. So let's go ahead and do that right now. All right. Let's go ahead and try this again. So let's go up. And if I hold space, ta-da, we are adding sand. Look at that. Right from our mouse cursor. Isn't that amazing? Now, I want to be able to add stone, so we'll figure that out next. All right, I said I wanted to add stone, and there's a reason for this, and that's because we'll be able to make our water flow through a canal that we built with our stone. So for stone, let's just set it to 3. And because it's super annoying to have the mouse constantly going all over my screen, what I'm going to do is private void start, and I'm going to hide our mouse and lock it to the center of the screen once we click play. So let's do cursor dot lock state is going to equal lock state dot cursor lock mode dot locked. Yeah, so let's just test this out really quick. And also one other thing we need to change, because every time we click the W and S, we're putting water and sand. Let's change that really quick. So automata, voxel automata. Instead of S for sand, we're gonna say T for sand and Y for water. It really doesn't matter. I just need it so that the other keys are not being used all the time. All right. So let's go ahead and full screen this game window because I want to get the full experience. Now if I move up, what I'm going to do is I'm going to click move up. Oh, that's water. Okay, so I set it to water. Let's quickly fix that in the player controller, or the voxel target. Let's change it to 2. I forgot rock is 2, not 3. Now if I click play, let's try that again. And let's see, if I click spacebar, I place a rock. All right, and I'm just going to quickly fast forward this while I place blocks down to build a little canal. All right, guys, and now for the moment of truth. I'm going to hold down the Y key and let the water flow. It is spilling over the sides. More than I expected it would. But if we look around here, it is flowing the way it's supposed to. Just what I was not expecting is that the water would do that. But yeah, there you go, water flow.